Good morning. Hi, Francisco. Is it audible? Hi, Francisco. Is it audible? Good morning, good evening, and good afternoon for the people who have joined. Thanks for your time. So let us get started. So I see there is a lag of around 10 seconds to 15 seconds. So I will go very slow. So the purpose of this presentation is talking about an experience of being in Oracle Bare Metal Cloud DBA. About me. So I'm Satyendra Kumar Pasalapudi. I'm currently working as a director cloud services at Apps Associates. I'm the co-founder and president for All India Oracle Users Group and an Oracle ACE director as well. So thanks to Francisco and team for providing an opportunity to talk and share the knowledge about the bare metal. About the bare metal. So the agenda for today is we will first go through the Oracle IaaS overview because there is a lot of confusion initially when Oracle launched the IaaS offering and they have announced the bare metal in the recent open world. So there was a confusion for me. So I will also confuse you initially and then we'll give a clarity of what is the basic difference between IaaS and the bare metal. And then in the bare metal, what are the components as a DBA one has to learn and transform to be called as an Oracle bare metal DBA. So this will be an almost like a 50 minutes presentation talking about IaaS, bare metal, a little bit deep dive into the bare metal, and then what are the things as a DBA we need to learn in order to become a bare metal DBA, because we will also discuss why and all those things during the presentation. And then initially to start with, I will just go with five marketing slides of Oracle, their positioning of the cloud from an Oracle perspective, and then get into the next things. So if you talk about the Oracle's positioning, any organization on the cloud has three offerings, and this has been a mantra or whatever we call it as, but this is a basic foundations slide which talks about the IaaS, the PaaS, and the SaaS. So when you talk about the infrastructure as a service, typically before the cloud, what was we were having is we were having the on-premise where it can be a co-located data center or it's an on-premise data center managed by the organizations themselves, where networking, storage, servers, virtualization, OS, middleware, runtime, data, and application are being taken care by the organizations itself. But when the cloud has started, predominantly with AWS coming up almost like 10 years or 12 years back, the infrastructure as a service piece, what they are talking about, where the public cloud providers are talking about is till the virtualization layer is managed by the provider. And after the virtualization, once you request an instance, they will provide you the instance where you can install OS and middleware runtime and all. So you're responsible for its backup, you're responsible for the applications running on it, you're responsible for installing it, taking care of it, which is nothing but an infrastructure as a service. Then we talk about a platform as a service, where the till the OS middleware runtime is taken care by the provider itself and we manage. So most of our Oracle databases has some offerings on the PaaS side. For example, the database as a service falls into this platform as a service. And we have, if you're talking about Amazon Story, it's like an RDS, relational database service, where Oracle can be used as a service. And then they take care of the backup, they take care of monitoring. It's only we use it as an end user. And Java as a service from Oracle. All these things are falling into the platform as a service. And we have a software as a service where we talk about the applications, the data, runtime, everything is taken by the service provider, which is nothing but your salesforce.com or the cloud ERP or the Oracle SaaS offering or the ERP solutions is completely software as a service. So this is just to give you an idea of where exactly the our offerings have been fit into. So today our discussion will be more on the infrastructure as a service, and this is another um, way of talking about what exactly the IaaS, PaaS, and SaaS. So on-premise people say it's a personal managing a personal car. IaaS is getting a leased car. Then we have a PaaS, a rented car, and a SaaS as a city bus, which is like a public offering where providers do everything on their own. So coming back on the Oracle's positioning, see Oracle, what they have done it is they started from a SaaS initially, got into PaaS and the IaaS. I agree they were late in the market. From an IaaS perspective, they just launched a couple of years back. So the virtual machines, server, storage, and network and data center fabric is where they are talking about the infrastructure. And the platform is from the database application. They have lot many products which have come from their acquisitions of their own homegrown products like integration, identity management, process management. Multiple products are there under the platform as a service offering. And we have the application layer, which is SaaS offering, which is where your the Oracle Financials, Fusion, all those things coming into picture. So what is the future strategy or the vision of Oracle Cloud Vision is we have IaaS for the legacy applications. We have SaaS for your sales, HCM, ERP, and CPQ, Telio. All these things are the extensibility framework. And we have somebody wants to develop on their own the applications using some of those Java as a service, database as a service, or the database container service, or the data container service. All these things falling into the PaaS offering. And we know Oracle is very popular with the BI as well. So they have something called the BIX, and there I think right now they're modifying this name as the Cloud Analytics platform. So what they're saying is, if an organization has a large footprint of multiple applications, multiple softwares running from multiple organizations, Oracle is the right place for them to put their workloads, legacy workloads, which can't be modified into SaaS, onto the IaaS, some of them into SaaS, integrate them, and put it into PaaS and PIX. These are some of these. They are coming out with like cloud IT shop as 100%. Now, as a partners or as an end users, they are providing as an option to come out with a migration strategy from business operations to the cloud platform with 4 aspects. One is SaaS, PaaS, and IaaS. And then also they're talking about something called Cloud at Customer. They announced last year at Open World. Earlier it was like a cloud machine they talked about early to 2016, but at Open World they talked about the cloud machine. So if somebody wants to have the same stack which is there running on premise, similar to that of the cloud, they can go with the cloud machine which is behind the firewall. So this is where they are talking about the strategy of converting customers into the cloud. Now, sorry, to talk about the comparison, this is a Oracle slide. So when you talk about the comparison between the other cloud providers which are there in the market, we have SaaS, PaaS, and IaaS offerings. If you just see, Oracle has a largest footprint, and because of the nature of business, how they've grown, how they're converted into an application business as well from a SaaS side, and IaaS, they just started off. But when compared to others, I don't want to spend much time here, just to give a broad spectrum of what offerings from an Oracle point of view. So let us talk about what exactly an IaaS, the infrastructure as a service portfolio. Then we will talk about the bare metal, what is the difference between bare metal and the IaaS and all those things. But one thing I want to spend a few minutes in this slide, maybe 5 minutes in this slide, because when an on-premise DBA has to work on the cloud, what is happening is the mindset has to change because when an on-premise, you are dependent on your network administrators, system administrators, storage administrators, vendors for providing you the infrastructure, what is needed for a DBA to install as an Oracle database. But, and there in an on-premise, what happens is it gives you a server, which is a direct attached storage plus a SAN kind of architecture where you put your database, which is heavy IO centric on the SAN, and the SAN and the database are connected via fiber optic so that the communication between them very fast and happens. But here, on a cloud point of view, when you talk about, when you say and when you request to somebody in your organization who is taking care of the cloud, we're saying that I need an 8 GB or a 16 GB RAM with an 8 CPU box, or a 64 GB RAM machine with a 16 CPU box with an X amount of storage and highly available, highly performant. When you request that, so how in the cloud world is changing is everything is interlinked, interdependent, and modular way of activities. For example, when you request an instance in Oracle, they call it as a shape. So when you talk about a shape is nothing but the kind of sizes the instance can be available. So this is where the flexibility of cloud comes into picture of auto scaling. It means that I got an instance of a shape X, which is 4 CPU and 16 GB memory, and I wanted to upgrade myself to an 8 CPU and a 32 GB. You can just stop the instance and start the instance. You can modify the shape online. That's where your scalability comes into picture, unlike the things what we do in on-premise. So what we need to do is we need to attach or while creating an instance, we need to inform uh, the Oracle cloud or the interface that I need instance X with a shape Y, which is like 4 CPU or whatever it is. And then you need to if there is always a possibility of that's the beauty of the cloud, where the virtualization has also had it in on-premise, where you have a pre-installed very hard operating system and prerequisite software set installed already. We call it as an image. So we have to attach an image to the instance, which brings in the pre-installed the software or the operating system, whatever it is. And then we need to provide and attach. So if we are already talking about like attachments, it means these are like a coupled things. So we're talking about public IP, we need to provide to an instance. Then comes your storage. What is your storage requirement? How much I need to provide a storage for the database? What kind of storage? How performant it has to be? All those things comes into picture. The NVMe storage, which Oracle talks about, the solid state drives, volatile in memory solid state drive, which is the fastest, which has got the best IOPS guaranteed because it's a solid state drive. So how much storage volumes I need to attach, what needs to be done, all these things has to be taken care. And you can attach maximum of 10 storage volumes to that particular instance. So one thing here is the storage and the instance, as they're attached, when I say attached, they are not local storage. There will be a small amount of local storage will be given, which is we can just store the things there, but once you restart the instance, those local things will be gone. It can use only for a temporary purpose. But actually the permanent storage is where the storage volume, they are talking to each other via a network. Unlike in your on-premise, they're talking to each other via SAN fabric, but the optical fiber fabric. But here you're talking to a network, and to access your instance remotely, you need an SSH public key. The other thing is there are a lot of other things comes into picture when you talk about an instance in a cloud. Is the security comes into picture, the majorly the security and the network. When I say network, so we need to say that, okay, who is eligible to access this instance, who is not eligible to access this instance, and which is part of which the VP, the virtual private environment, the virtual cloud network, we call it as an Oracle VCN. And the protocol, what exactly the protocol, access rules from a security point of view. Only the application tier wants to talk to the database. No other guys should be opened, and your backup environment should talk to the things. So those are all the things where one has to control just launching a server. And these are all the areas one has to be like, these are the relation between the multiple compute objects. And if a DBA is aware of these things, their job becomes very easy rather than requesting for, and all these things are a GUI based, next, mostly. And you have other ways of doing it, like while you are automating it, we need to have the automation DevOps kind of frameworks to be written to do that. But this is very important for you to start the process. And to talk about the next one is your what exactly the infrastructure as a service offerings from Oracle point of view. So here we have three things: compute, storage, and network. And in the storage, we have object storage, block storage, archive storage. So for example, I want to talk saying that, okay, we have a database, highly performant, we need. So we need to have an object, the block storage. And the block storage, what kind of make you're talking about, the NVMe disk or whatever. Then we are going to take a RMN backup, needs to be placed into an object storage because that is highly redundant and easy to restore and copy back. And we have something like a tape drive in our on-premise, like an archival storage. And all these are options available provided by the Oracle Infrastructure as a Service. And we talk it as a network. So we have something like your on-premise data center, because most of the organizations might coexist, and which is not that overnight they turn the things onto the cloud. So there might be some dependency on your hardware refreshers or an applications, multiple things. So the strategy will be multi-stage or multi-step approach to the cloud. So the coexistence will work, or some users will be from the office has to connect to the thing. So we need a direct connect or a VPN connection, talking from an on-premise to the public cloud, which is your Oracle cloud, and how the traffic is. And if you want to talk about a backup on-premise and then take the backup onto the cloud, you need a connection between your on data center and all. So there are a lot many options available in the network space. They're providing it. And compute space, they also have, like any other public cloud providers like Azure or AWS, they started with general purpose compute, high performance and design dedicated compute. And they said, okay, because we are very good at engineered systems like Exadata and all, I will give you as a service. We will offer you as a service. You can go ahead. So there are a lot many compute options which Oracle talks about from an IaaS perspective. Then what happened is, as they were very late in the industry in terms of the IaaS, they have thought about what is the difference which we can make. And that's where they launched something called a bare metal, where the multiple hypervisors they are supporting. For example, when you talk about an Oracle Elastic Compute, the virtualization is already done by Oracle and gives you a compute. And behind the scene of virtualization can be an Oracle VM or the Oracle VM, again based on your Gen hypervisor and all those things. But bare metal, when they started, they announced that I will give you a raw server where you can install or bring your own hypervisor. It can be anything you talk about. You bring your VMware or any other hypervisor, you install it. I'll give you a complete access to the server, but you need to guarantee me a 32 CPU minimum license or the cost and all those things. But the customer has given a flexibility of running whatever they are running on premise, exactly matching and lift and shift of that particular thing on the bare metal point of view. So that was the offering when they initially started off. So the bare metal is one of the offerings of the compute Oracle IaaS, the Elastic Compute, dedicated compute, engineered systems as a service. And we have something called the CloudWatch, which is similar of a CloudWatch in AWS, we talk about, where this is basically monitoring of your instances, monitoring of your Elastic Compute and your network compute. So behind the scene, it is the EM12C kind of features behind the scene. So CloudWatch is another good offering from IaaS. And they have all these like storages, multiple storages. We talk about object storage, archival storage, and database backup service, software appliances. Then we have bulk data transfer. If you want to migrate a 10 terabyte database from your on-premise over a network, it is impossible to migrate in stipulated time. When I say impossible, in stipulated time for your failover and all. So that's where they talk about the bulk data transfer, similar to AWS, what they provide an export import. And even in AWS, we have something called the Snowball. They are talking about the ZFS appliance can be shipped onto your on-premise and then they can get it back. So these are some of the things to talk about from a storage point of view. Now let us talk what exactly this bare metal cloud service. So when you talk about a bare metal cloud service, when they started, they were like, we are already late into the market, so let us do some innovation stuff. And what they've done is they have termed this bare metal, and now they are going to replace as an Oracle Cloud Infrastructure, not to confuse people, like IaaS is different or bare metal is different. So what they have done it is, let us first go into a bare metal, what exactly, and then we'll clear that particular confusion. So they call it as a generation 2 or a modern cloud infrastructure. And they are building up the data centers right from the ground up, because this infrastructure, which they're talking about, the differentiator from the other public cloud providers, has to be built from the scratch. And there is a separate networking fabric, there is a separate software being run at the behind the scene. And what they did is they formed the A team at Seattle. Almost like 3 years back, they invested on this. And why Seattle? Being the cloud capital, where you have Azure, Amazon up there, and then most of the team members, they're from all these other cloud providers. They formed a team hiring from Azure and AWS, who have designed this bare metal, because they know how they have done multiple times the infrastructure built on the competition. So they know what exactly the pitfalls, problems, and all. So they have come out with key things saying that the bare metal cloud service or the generation 2 or a modern cloud infrastructure will be a different from the competition, which is very high performant. And the key goal for this is to design for the enterprises, because enterprises needs that particular big high performance thing. So, and then rack is one differentiator where we need a rack. We have been using it for years together for high availability and performance and multiple other advantages which we can't get it on the public clouds, on other public clouds. There are options they're providing us, but they're not so interesting for us, because we can't put something on an instance store and say if something breaks, we have to restore it again. So those racks are not the original ones, but this is where they're talking about behind the scene. I looked at it, it's like it's ODA which is running. Initially, they're giving a 2-node rack with an ODA behind the scene as a service, and then you can run your applications on that. So what they've done is they combined the first generation iOS and on-premise. What are the benefits they got for first generation IaaS, which is like Azure and AWS, they call it as. So all this elasticity of adding capacity in minutes, only pay for what you use, all those cloud advantages they retained, and added the raw iron performance, dedicated hardware from a bare metal point of view, and which can be launched in minutes. And you can bring your own hypervisor. And you don't want a hypervisor, you can just create raw like your on-premise. And because the hypervisor brings a performance degradation a little bit, because the resources are being shared, but not all workloads require a highly performant. Like Oracle database can be an highly performant, but an application e-business suite application tier can be on a virtualized environment. So the combination is possible, and that is also possible in the bare metal point of view. Now, what exactly the latest technologies, what are the differentiators, why modern cloud infrastructure is really a differentiator from the Oracle point of view, is what they have done is 4 things. The availability domains, this is something new for a DBA to learn. If you are a DBA who is already in AWS, you are aware of multi-AZs, they call it as availability zones. So what we talk about is availability domains are nothing but 3 distinct data centers 10-15 miles away or 50 miles away, which are in the same city, but they are like 10-15 miles away, ensuring that if some disaster happens, it is not affecting all. And three data centers they form as an availability domain, and that is called a region. And the region to region, which is like one is Phoenix, other one is Virginia. For example, if you want to have a highly disaster recovery site, you can choose one of these things from a bare metal or the modern cloud infrastructure, and they're coming out with other regions very fast, by Frankfurt and London shortly, then India and Asia Pac, and many more in US and Canada. So they're planning, because this is like ground up, they created the entire data center, and that's why they call it as an availability domains. And then the connection between these data centers, that's more important. It's not the data centers, but again, how we are talking to each other, what is the latency, the network latency, and all that, they're ensuring the better ones. And the other one is the major differentiator I see, being a DBA on being an Oracle DBA for the last 5-6 years with other public cloud providers. This is very challenging and interesting for us, because a non-blocking network flat, which enables noisy neighbors. So if somebody is running a big job or an ETL or a batch job, from a one VM, the other VM is getting affected, which is sharing the same hardware physically behind the scene. That is, I will talk more about that in a slide. And we have something called off-box IO virtualization and automated hardware wiping, which is very much required, because automated hardware wiping is because when you're in a public cloud and you are just dismantling one server or an instance, we don't want that data to be read by anybody else, because the sharing, and also they have something like hardware wiping, they're doing it. But off-box IO virtualization is another great feature, which is possible only in this kind of modern cloud infrastructure. And direct attach NVMe storage, they announced the last Open World. This is the fastest, highest IO workloads they talk about. And so these are the four differentiators which Oracle is stating that the modern cloud infrastructure will be. And let us go deep into those things, how exactly they talk about. So as I just mentioned about the availability domain topology, so it is for disaster recovery things and all. So when you are designing your system of running an Oracle database or an e-business suite or on a PeopleSoft or a JD Edwards or a third-party home applications with an Oracle database, we need to think about keeping the standby in another region or within an availability domain. Depends on the customer's requirement and the performance and all. So this is where every region comes with 3 different ADs, availability domains, and that has to be chosen while you are launching your the public cloud virtual cloud network, which is your private cloud kind of thing for your customer. So what happens, this slide is very important, which is the BMCS high scale, high performance network. So no noise neighbors and all they said. But one thing is, as I told you in the beginning of a presentation, is the instance and the storage are talking via network. They're not talking via a direct cable or attached, like an SCSI table attached to an compute or the motherboard, or a fiber optic connected from your server, and then talking about your SAN storage. Absolutely, that is not the case in the cloud. So they are talking via network. And what happens in real world is the performance is really, really slow, because when you attach a storage to a compute, the memory CPU resides on your compute instance, and the storage, it, even though it talks locally, it is like it goes multiple hops behind the scene. It has to do multiple hops and then talk to the storage. And that's where the most of the performance challenges when you migrate your on-premise database to the any of the public clouds, even you talk about IaaS. But from a modern cloud infrastructure and a bare metal, what they've done it is, because they have ground up created these particular data centers, there is something called a non-oversubscribed Clos network. So Mr. Clos is like 1960s. He invented something called a Clos network. He named it. It's a telecom name for it. Most of the telecom organizations uses the Clos network. So what happens here is the entire data center is divided into 2 parts. For example, the left side and is right side, or multiple pods. For example, there are 10 pods, and each pod is nothing but like a switch. Under the switch, everything is connected, all the servers. So when you talk about a public cloud, we are having storage, we are having servers, we are having, so everything is an IP solution. So the storage wants to talk to network, storage wants to talk to compute, they have to talk via network. That's how it's possible, just like a SAN architect, NAS architecture. So what is happening is, here they have a, on the right side of the screen on the top, when you see this, there is something called three layered: 1 1 1, 2 2 2, and 1. So what is happening is, the left side, imagine a compute wants to talk to a storage on the right side, which is number 2. So the middle thing is the switch, is a backbone switch, where it is directly connected to the middle switch, and middle switch routes to the, so the entire concept of this bare metal, this network, is from a routing then switching. So a routing versus switching is the technology they talk about. That is the comparison between others and here. So at any moment, only 2 hops is required to talk to a storage and the compute. That is the major differentiator for a bare metal or a modern cloud infrastructure. And that's the beauty of that's where they're building up right from the ground up this particular things. And this is going to be solving a lot of problems from your performance point of view. Application tier talking to the database tier doing an ETL overnight to a data warehouse database or an Exadata as a service. So what do you talk anything in the enterprise, the data movement across these particular subsystems is heavy, and that heaviness can be solved using 2 hops, your network, plus a small communication happens across. And the beauty is, they're talking about in an availability domain, they have their capacity of 1 million network ports. So so highly scalable from a number of compute instances and all, and maximum of 2 hops, as you know, and predictable low latency of 100 microseconds. The round trip, which is like less than 100 microseconds, not milli. 1 second divided by 1000 is milli, and 1 second divided by milli is micro. So you can imagine how the round trip between this particular the communication happens very fast, and that is what required for any organizations with a 10 gigabit band connectivity between across all these ports. When I say ports, they can be a storage, they can be a compute, they can be an whatever you call it as, which are available in the public cloud as a service. So that is a major differentiator, which I liked it very much when I looked at it, researched some things, gone and did some the pings from here and the other public cloud providers. Plus, when we started installing for e-business suite on this, it was fantastic. It was zip through. And let me talk about what exactly all those things a little bit later. But there is something called off-box virtualization. So they have created something called off-box IO virtualization. So what they're trying to do is, okay, let me first clarify why you're talking about virtualization when you talk about a bare metal. Then it gives you clarity. So what they did is, bare metal, they're saying you come along with your whatever you want. So it's a raw power I will give you, and you can install your hypervisor. But slowly, over the period in the last 1 year, after Open World, they said, let us now make this bare metal cloud service, because it is highly performant, the network and all. Let us introduce the virtualization on these servers and create and provide them as a service of a for example, there are few shapes. They'll give those shapes. Everybody doesn't need a 32 CPU box. They need a 4 CPU, 8 CPU. So what they're doing is, in the 32 CPU, Oracle is creating the hypervisor, which is, I heard, don't quote me, but I heard it's a KVM hypervisor rather than a Gen hypervisor or an Oracle VM. So it's a KVM based hypervisor, which is the future hypervisor, which is very good. So what they're trying to do is, now they have got the infrastructure as a service capability of compute, storage, network onto the bare metal, added that to the bare metal with this clouds, this entire infrastructure. And this is my understanding, and don't quote me if something is different, but this is my understanding. So what they've done it is, and they've added that same functionality of launching an instance, launching a compute, launching a storage, and attaching, and all those things, capabilities, they have made it up. So now the VMs are possible in the bare metal, and which is equivalent to your IaaS offering. So slowly that IaaS will become the cloud infrastructure, and bare metal will be the modern cloud infrastructure. They are pushing hard, and they are not, and it's not for everybody, but it's only for enterprises which they need heavy things, but they're ensuring the cost remains the same behind the scene. And so what they have done here is extra to that what bare metal is, they have taken care of the IO virtualization. So when you're using a KVM hypervisor, so what they're trying to do is, if one machine has got 10 VMs running in a single machine, the 10 VMs will share the compute, will share the memory, will share the IO. So what they have done is they remove this IO from that particular machine and put it into a network fabric, so that the no noise in neighbors, and then if one guy is running a bigger workload, the other guy is not affected. So this is something called an off-box IO virtualization. So virtualization within the network from an IO point of view. So this is where they were talking about the new feature of things. Now talking about putting it all together, the compute and storage, you have an option of running bare metal hosts, NVMe storage, VM, engineered systems. Sorry, actually, the one slide here and there, but whatever the slide I'm talking right now is putting it all together, the reliable, predictable, flexible, fast. So any middle box, you are attaching it to that. So what is happening is the modern cloud infrastructure, they can talk to each other, the engineered system as a service, VM as a service, NVMe storage attached to a bare metal host. And the other beauty I want to tell for a DBAs is, when in an on-premise world, when a SAN is recommended by us, when your storage administrator comes to you and asks for you what kind of RAID level you need and all, we used to provide them the knowledge of RAID levels, and then the ASM comes into picture, redundancy levels and all. So whatever we are trying to do on the ASM and all those things, choosing the RAID levels at the bare metal hosts, you can do it. You are the owner for it. You can do whatever you want, similar to the on-premise, because they are going to attach whatever the NVMe storage you requested for that particular host computer, which is bare metal, and then you can create RAID levels and all those things. Plus, on the right side, you can have a VM. You can attach the VM storage. You're not supposed to do a RAID and all. VM does already and highly redundant storage they provide you. So all these things are putting together is where the new modern cloud infrastructure data center looks like. Then you talk about the compute, the database, block volumes, object storage, virtual cloud networks, VCNs, IP load balancing, because load balancing is one thing which we require for a high availability of an application tier, so that the traffic is diverted across 50-50 or 0-100. It depends on active, passive, active, and all. So what right now the current bare metal cloud service offerings will be all these things. So you can have your cloud native workloads, big data workloads. You talk anything, you can run on these servers. You can run and choose Windows workloads. Absolutely, yes. So to sum it up, so that the confusion between the IaaS and bare metal has now got cleared. Even that is the same way I got it cleared for you. I got it cleared myself working with both the things for the last 1.5 year, when we got that from the previous open world, when Oracle has given us the access from an ACE director's perspective. Thanks to our Thomas Kurian for providing us that particular 1 year access to the Oracle infrastructure as a service. But then we, as an organization, which is like from an apps associates point of view, we have done some work towards that from a bare metal and all. So these 8 things, a DBA, as a DBA, if you want to become a cloud DBA for bare metal, you need to understand what is IAM, what is database as a service, compute. So there are 2 things here I want to talk about. One is, say, database here on the screen, which you're seeing, is nothing but a database as a service. Compute you're talking about is a VM where you can install your own database. For example, the eBusiness Suite you wanted to migrate onto the cloud, and you don't want heavy customizations and you want to own it, you can spun up an VM instance and do the e-business suite, the database on one VM and application on the other VM. Or you can keep this particular database as a database as a service. That's where your second tab here, the database, talks about. So block storage comes into picture when you attach that block storage to the compute of whatever the VM shape you're talking about, and or physical bare metal. And load balancing is a service which was only publicly available, but now private load balancers are available within the things. So I will show you how the architecture looks like when you talk about networking. Absolutely, that's a predominant thing. First thing which you start with networking, and then the IAM, then the compute storage, then the database load balancing, and auditing comes into picture. So object storage is nothing but your a backup storage where you can store files, similar to Amazon S3. So what exactly this IAM? As a DBA, you should learn the IAM is. This is basically a cloud identity and access management. So it lets us control the whole access of the entire cloud resources. You can control what type of access or group of users to which specific server, which specific things. So this is one area which is very easy to learn. Nothing, just like if you have a background of Oracle roles and privileges, that's what we used to do for a particular schema. What is a role for a particular user, like a DBA, non-DBA, or an application, Scott, all these things we used to play around this. The same concept remains here, and for a DBA it is easy to learn those things. So how they have defined this is within an IAM. So this is just a startup. I'm not making you a bare metal cloud expert overnight or within 1 hour. This is just to give you a beginning to it, so that you can just explore further. And if you're talking about a resource, everything is a resource for this particular IAM, which is a compute, a storage, a virtual cloud network, which is nothing but we call it as an Amazon virtual private cloud, subnets, your basic subnets and route tables, and users point of view, who wants to manage these BMCS resources, or which is like an administrative panel, or other users can be like the people who are responsible for that particular server or a VM, and you can just create a group of it. For example, in the real-time environment, we have something like network administrators, application administrators, and all. And the other thing is they call it as the compartments. That is one differentiating factor here. So when they talk about a compartment, is, for example, in our data center, we have something called test environment, or a development environment, or a production environment. So we can create those compartments, and within the compartment you can create, so that we have to write rules to talk to each other, provide that. Similar, your mapping to your data centers, which you are managing along with your other administrators, and tenancy root compartment at an organization level. So it is like apps associates as an organization will be given a root, and there I can manage 3-4 customers as under compartments, if that is one option. Or if I'm an organization like a GE kind of thing, and say, okay, production, non-prod things, and a home region where a region is nothing but in which region you're launching those instances and all. And we can create a policy to give the provider a level of access. And I talked about shapes, I talked about compute a lot. So what exactly these particular computes are? There are two things, as I told you. One is bare metal, where they will just give you a server and they will give you an access to it. You manage it. And if you forget a password, they don't have even the customer, the Oracle can't provide you an alternative. They have to scrap it and then do it again. And virtual machines, that's where you see on the screen on the right side, I just mentioned standard VM with one OCPU. So this is a major differentiator between other clouds and here. OCPU is nothing but equivalent to a core. A vCPU is nothing but a thread of a core. So others talks about vCPUs. Here it talks about OCPU, which is nothing but the actual physical core and memory and block storage only, and NVMe. So if you want heavy IO, servers, for example, for database, you have to choose the dense IO at the bottom, which is 4 CPU, 60 memory, 60 GB RAM, and 3.2 terabyte of NVMe SSD drives. And whereas the top block storage, they are not much performant. For an application tier, you can use those. So this is where one has to learn what needs to be, you can choose and play with it. And then the difference between NVMe storage, block volumes, and object storage. So NVMe storage is nothing but highly performant, where 4 million host IOPS, when they talk about, they're talking about a raw server with a big instance. It can be used for data guard replication, or your performant databases. Block volumes, again, they provide. So it is through an iSCSI based thing. It's not an the SSD drives, but a regular drives. And the object storage, where you have your backup strategy designed to put it in a object storage. There are a lot many other usages, just like S3. So talking about the bare metal database. So what happens here is they are having a lot many. So what happens there is, if you talk about bare metal database, the database service, you can launch it as a database service. So earlier, when I told you compute, in the compute, we can install the entire things of your own. You can install your Oracle database, 11g O2, or whatever the patched versions, whatever you want to retain, you can retain it, because you are bringing your own license. Here, when you talk about database as a service, you're paying it. So what options available for you is, they have launched recently Exadata DB systems, which requires an extreme performance. So they have talked about 11g 12c release 1, release 2, and bare metal DB systems, 1 node and 2 node rack systems. So if you see here at the bottom, rack local storage 1.72, the shape name is called rack local storage, and the data is 5.4 terabyte, and recovery is 1 terabyte, and three-way mirroring, two-way mirroring, and raw storage. So you can choose whatever you wanted to take care of those things. So talking about the other feature which the bare metal things which DBS has to aware of it is your virtual cloud networks, or VCNs. So basically these are like logical separation of your entire organization's things, so that it's just like a virtual cloud for you, and nobody can peep in, the others can't get in. So there is like a restricted environment, and we have to log in inside and open up access to the external world. And how we are connecting from your on-premise, there are multiple options. You have through the VPC, we have an IPsec tunnel can be established, MPLS, Fast Connect, and we have some third-party providers like Equinix and all in the. So the Equinix and all are connected directly to the Oracle data center. So if you have a last mile to the Equinix, and then Equinix is already connected to the multiple data centers of Oracle Cloud, so it becomes easy for you. And load balancing is another major feature which we require as a DBAs. And if you're an apps DBA particularly, you are doing all those application installations and all those things. That's where this load balancer will be very handy for you when you're talking about. So the beauty here is, if you see on the left side, on the top, we have something called AD1, AD2, and AD3. So availability domains across, I can have a load balancer, and the traffic can be diverted onto all these three. So very highly available, and if one AD goes down, your services are still continuing because the traffic is routed to the other ADs. So those things are there. And SSL offloading, end-to-end tunnel termination SSL, the secure socket, so that you are not talking about from a security point of view, everything is taken care. And traffic management, you can add dynamically, add remove instances to the traffic. So behind the scene, it's just like this auto scaling feature, where you can just scale based on your traffic when you're talking about more number of users coming up. If you are a web application where we don't know how many users are going to hit your things. So Summing it up, what we discussed is compute, storage, load balancing, backup, cloning, security, database, and compute is what the enterprise applications needed. And as a DBA, you need to have the knowledge of all these things, because till now we have been more popular on the database, backup, and cloning, but not on much on the security. We leave it to somebody else. But the cloud has really changed the way things work, because organizations can't afford to have a network administrator in the cloud, an exclusive network administrator in the cloud, or an exclusive storage administrator in the cloud. So who got that advantage is the DBAs, who can just scale up to the ladder, get those small, because one-time jobs these are, like attaching a storage is a one-time job, but once your Oracle database installed, you're doing many things inside day in, day out. So you will be the right guy to take that particular thing and go to the next level and see how things. Now, to talk about sample EBS architecture on bare metal, simple thing is you have a virtual cloud network, VCN, created on the upper top layer, and we have a load balancer, and that load balancer is having one node of application tier and the other node, and you have your database on an AD1. But it's up to you. How do you want to take care of it? If you say AD1 is a primary and AD2 as a secondary, you can maintain it if you want a highly redundant things from an database as well. And to sum it up, this is how a typical architecture diagram of an enterprise application on a BMCS looks at. Is we have something called a bastion server, which is where we normally give it as like people will log into that server and get into the thing. So here, one thing I wanted to tell you guys is the AD1s, AD2, and we have subnets created under the AD1, and within a subnet you have your application tier, and we have another subnet for database, so that you are securely storing and ensuring that isolation is given. And then we have the IAM service, audit service, and object storage, which are attached to a particular component within a particular thing. So networking point of view, it's a little bit tricky, where you need to learn what is a subnet. If you're a hardcore DBA, you can just easily learn what is a subnet, which subnet you are attaching it to, and all those things from an infrastructure point of view. So to sum it up, this is a comparison slide which are created for AWS, Oracle IaaS, and Azure. So if you see here, if you're good at one cloud, your job becomes easy for the other clouds. AWS, Oracle IaaS, and Azure, all these things, the concepts remains the same, but they're talking only of the vCPU, OCPU, CPU cores. Simple thing. If you see availability, data center reasons, availability zones, availability domains, availability sets. It's only availability remains the same, and then all the things are changing. And if one is good at AWS, he can become very easily an Oracle IaaS. If one is good at Azure, he can learn Oracle IaaS very easily. If not, also you can start from the ground up. To summarize what we have discussed, so the purpose of putting this thing is the DBA has to scale and learn few things about the storage admin, options available in that particular cloud where he's working in. Network, absolutely yes, but they're all the concepts only required because we are setting up the first time, and the IAM rules, all these rules are GUI based, so easy to select and easy to put. But one thing is, this is very critical, and where we can't let go, open up to the public for every port, and then we are like immediately few minutes your entire server will be compromised. So security and network has to be one has to upgrade themselves, so that you are not depending on somebody and maintaining it. So DB has, like, the same analogy I want to talk about is when ASM launched. So there was a fight between who's going to own the ASM. It's a DBS or the sysadmin, the storage admins. So ultimately ASM is managed by us, where we have learned a few concepts and we have done it. Same thing, on the same analogy comes to the cloud. So who's going to learn that? So DBA, if he learns and upgrades from storage admin, network admin, and security, which are like the components within the bare metal or the other IaaS, he becomes the go-to guy on the cloud for most of the workloads running inside. So I will stop here and wait for your questions. The next 5 minutes, I'm going to talk about the questions in the chat. So please provide your questions in the chat window to answer. Chat window to answer. Okay, I think I'm not getting any questions here, but again, this is my email ID and my Twitter handle. For any of you wants to reach out to me for any of the BMCS help, I'm feel free to reach out to me. Definitely, I can help you out. Okay, I'm just getting few of the things. Okay, thank you everybody, and thanks Francisco. Look forward for similar kind of things in future. But thank you very much for giving an opportunity. It's a different experience because I'm used to more of the conference sessions, but this is good, and I like the quality of the things, the webinar jam. So thanks for your time, patiently listening to me, and thank you very much. So please reach out to me for any of your questions in future if you're related to the BMCS. I am very active in the LinkedIn and the other social networks. So I'm already connected. You can just connect me with me on the social network for any of the things. So thank you. I'm just stopping this here.